Hello again, class. As you can see here, I'm preemptively celebrating Christmas, and I will be for the next 24 days until we arrive at Christmas Day. For me, these are the 24 days when I can play Christmas music until all of our ears and minds go completely senseless. And so I hope that you can get used to that through this holiday season. I'm excited. I hope you are too. All right, today's lesson is going to be on 5.1, chapter 5.1, linear functions. And if you follow along with the notes, I have the notes in front of me, and so I'll try to spell out each section, exactly what you should be writing. Everything should be in this lecture, and a lot of it we've already covered. So stick with me. The first thing that we want to do is define a few things. And so the first thing we're going to define is a function. You guys have learned about functions before, like you've learned about machines. And so maybe some of your teachers have drawn machines to represent a function like this. You have an input tube and an output tube. And into your input, you do x. And then your function is f of x, is how you say it. So f with parentheses x, and when you plug in x, it goes into this function. That function says f of x is, let's say, when you plug x into the function, f of x, that means you multiply it by 2. So plug in x, goes into the function, which is 2 times x, and then out, when you shoot it out, you get your answer for the function f of x. So let me explain this in an example so it'll be more clear. If you plug in the number for x, so suppose you plug in a 4. The 4 goes through and it drops into this function machine. And when you multiply the 4 by the 2, it shoots it out and you get a final answer of 8. So f of x is the function. If x is 4, you plug it through the function, it comes out as 8. So it's a lot of math lingo to describe a very simple process. And oftentimes, f of x can just be replaced with y. And so, in the definition part of your notes, you should write a function is a pairing between an x value, and we'll call this, for our own purposes, a y value, so that for every x, there is one y. So a function is, when you plug in one x value, you get out one y value. Now, in this chapter, we're talking about linear functions, not just functions. So linear functions are this. Linear functions are functions that when you graph them, they create a straight line. So suppose you graph a function on this grid, and that function creates a straight line. And you guys kind of remember how to graph. That means if you have an x, and you plugged it in, then you get out a y. So you take your x and your y value, and you plot those on the graph. So a linear function is one that creates a straight line, and we know it by the name, or by its form, y equals mx plus b. Okay, so for your definition, you should write both of these, y equals mx plus b, and a function that creates a straight line on a graph. The last part, the last definition, is function notation, which we've talked about briefly, and what I want you to write there is this. The notation's already there, and underneath the notation, you should write reads f of x is, and then next to the f of x, if you were to use it in an example, you would have some sort of, like we did with our machine, some sort of an equation. So let's say f of x equals 2x, and it would read f of x is 2x. So under function notation definition, you can write reads f of x is. And then for function notation, if it helps, if you want to write this down, it might help you. Typically, we replace f of x with y in an equation if we're graphing it. So you can write that down as well. So now the question is, how do I determine when an equation like y equals 2x is a function? So how do I know that y equals 2x can be written f of x equals 2x? How do I know? There's 3 ways, and I would like you to write down as much or as little as you need to, because if the sort of quiz questions and test questions I'll give you on this will be, it'll most likely ask you to define a function, and in so defining it, you'd be able to tell when an equation is a function. So you can write down as much or as little as you need to, just be able to define what a function is. So there's 3 parts to it. The first is the graph. So something is a function in a graph if the line that you're graphing never goes above or below itself. So if you had a line that did this, that would not be a function. No, very, very bad. But if you had a line that did this, that just hung straight and true, like that, it never goes above or below itself, it is a function. Even something like this, that would be a function because it never goes over top of itself or underneath of itself. Another way to define when something is a function is for an equation, if it simplifies to y equals something x. So there's a y on one side, and that y is alone. And on the other side, there's an x present. What that means is you plug in a number for x, and you get a specific y. If the y were to disappear, it wouldn't be a function. Lastly, if in a table you had an x and y column to describe x and y values, suppose that you had 1 for your x, and all of a sudden you had 2 values for your y. Suppose that the 2 values were 3, and then also where x equals 1, you had a value 4. That is not a function. Not a function. So by definition, a function means for every single value of x, there's only 1 y. Here there are 2. Next question, how do I determine the domain and range of a function? The domain is all x values. And by that I mean all possible x values that you could plug into the equation. So in a lot of equations, every single x value is possible. Now you may have a problem where it only lists a few values for x. And suppose that there was a question that said, what's the domain of this table? And it only gives you 1, 2, and 3. Then in this situation, you would say the domain is 1, 2, and 3. And when you write out domain, you will write it out like this. You'll do one of these little squiggly sideways curvatures, which look like a chin almost, with a little bump in the middle. So like Jay Leno's chin. And you write 1, 2, 3. And then you do the other Jay Leno's chin on the opposite end. That describes the domain of or all of the x values, which is the domain. The range is all possible y values. So in college, I had to look at an equation and say, what are all the possible y values that you could get from this equation? I'm not asking you to do that. What I'm asking you to do is similar to the last one, where if there's a table, you have x and y, and it gives you some x values, 1, 2, 3, and it says where x equals 1, y equals 2, where x equals 2, y equals 4, x equals 3, y equals 6. The range here is this. You write it with the same Jay Leno chins. You write 2, 4, 6. That is your range. And in order to differentiate between your range and your domain, you might want to write range next to it. So that is how you define, that's how you write the domain and range.